The greatest mystery of the universe is hidden in a place where even light cannot escape, where time loses its meaning. Black holes, the dark lords of space. Their gravitational pull is so intense that once something crosses the event horizon, there is no turning back. Not light, not matter, not even time itself. Scientists are striving to understand the true nature of black holes. But the closer we get, the more the unknown expands before us. There could be millions of black holes in the Milky Way. But what about the one closest to Earth? Could we ever find ourselves drifting toward a black hole? And most importantly, do even greater secrets lie hidden beyond this cosmic darkness? In this video, we will uncover the mysteries of black holes. Get ready for a journey to the point where the known laws of physics break down. By the way, if you enjoy this kind of content, please don't forget to subscribe to my channel and like the video. Your support means a lot to me. Welcome to my channel, Discovery of the Mystery, where we will uncover the secrets. Are you ready to face one of the greatest unknowns of the universe? Black holes are mysterious, cosmic anomalies whose nature we are only beginning to understand. They are so powerful and dark that even light cannot escape their pull. These objects warp space and defy the very laws of physics, making them extremely difficult to detect and nearly impossible to study. Yet understanding black holes is crucial to unlocking the deep secrets of the universe. But just how dangerous can these cosmic giants be? Finding a celestial body that absorbs all incoming light is an immense challenge. For this reason, the number of confirmed black hole candidates remains relatively low. However, mathematical models suggest that there could be around 100 million black holes in the Milky Way galaxy. While this number may seem overwhelming, considering that the Milky Way contains between 200 and 400 billion stars, black holes are actually quite rare. The birth of a black hole is one of the most violent events in the universe. For a star to collapse into a black hole, it must have at least 18 to 20 times the mass of our sun. When the star exhausts its fuel, it undergoes a massive supernova explosion, causing its core to collapse into an incredibly dense mass. From this point on, nothing, not even light, can escape its gravitational pull. Any object that crosses a boundary known as the Schwarzschild radius is doomed to be trapped forever. In the place of the dying star, a mysterious and terrifying entity remains, one that even the known laws of physics struggle to explain. One of the closest known black holes to Earth is an object called a 0620-00. Located approximately 3,300 light-years away, this celestial body is part of a binary star system in the Monoceros, a unicorn constellation. The second component of this system is an orange dwarf star, roughly 50% the mass of our sun. Every 7.75 hours, this dwarf star completes a full orbit around an invisible and unknown object. Calculations indicate that this hidden celestial body has a mass of approximately 6.6 times that of the sun, too massive to be a neutron star. This strongly suggests that the object is, in fact, a black hole. Black holes are not just cosmic monsters that consume matter, they also slowly devour stars. If a star enters the orbit of a massive black hole, its shape first begins to distort, then gradually gets torn apart. The outer layers of the star spiral inward, drawn into the black hole as if caught in an immense whirlpool. During this process, a bright accretion disk of hot gases forms around the black hole. And here lies one of the most terrifying paradoxes of black holes. While they themselves remain in absolute darkness, they are detected by the light they emit through the destruction they cause. Black holes may be invisible, but the devastation they leave behind marks their presence. In the vicinity, there are at least a few dozen stars, some of which may have planetary systems of their own. If, in the future, one of these stars drifts too close to a black hole, it will inevitably be caught by its immense gravitational pull. In such a case, it will share the same fate as its current companion. How a black hole interacts with other celestial bodies depends on its mass and the distance between it and surrounding objects. The greater its mass and the closer the objects, the stronger the tidal forces it exerts. These forces can deform stars, draw them toward a common center of mass, and even create channels through which matter from the stars flows into the black hole. If these tidal forces are powerful enough, the black hole can completely rip apart the captured celestial body, turning it into a massive ring of fire. Theoretically, planets can orbit around black holes, much like they do around a normal star. Contrary to popular belief, black holes are not insatiable monsters that inevitably consume everything around them. In terms of gravity, they do not behave differently from a star of the same mass. This means that a black hole could potentially have a stable planetary system. But how is this possible? There are a few ways a black hole could host planets. The first possibility is that the remnants of a supernova explosion, clouds of gas and dust, could coalesce under the black hole's gravitational influence, forming new celestial bodies. Small clumps of matter would first emerge and, over time, attract dust and rock fragments, evolving into planets, moons, asteroids, and comets. During this process, the black hole's hot accretion disk could provide warmth to orbiting planets, melting their ice. Theoretically, such a system could create conditions suitable for life to emerge. The second possibility is that a black hole could capture an existing planetary system, stripping away some objects while allowing others to settle into stable orbits around their new host. As a result of this process, the surface conditions of celestial bodies could change drastically. An icy giant planet could transform into an oceanic world, or a gas giant might lose nearly all its hydrogen, evolving into a carbon-based planet. Additionally, rogue planets or interstellar asteroids could be drawn in by the immense gravitational pull of the black hole. While such planetary systems have yet to be definitively discovered, there is no reason to assume they cannot exist. If a planet is positioned too close to the center of its system and the black hole has a sufficiently large mass, other factors come into play. The high-temperature gas streams that form the accretion disk can strip away the planet's atmosphere, and the friction effect gradually slows its motion, drawing it ever closer to the black hole. Eventually, intense tidal forces will tear the planet apart to the smallest fragments. The resulting debris continues to move within the accretion disk, slowly dissolving in the hot gas environment until it is finally consumed by the black hole, becoming an inseparable part of it. There are thought to be three main types of black holes in the universe, primarily classified based on their mass. The first type is found at the center of most spiral galaxies. These are supermassive black holes, whose masses can reach several billion times that of the Sun. The density of matter at a galaxy's core is typically very high, leading to the formation of large luminous stars in close proximity to one another. These stars burn out rapidly, collapsing into black holes that grow quickly, often merging with each other to form even larger structures. As a result, these supermassive objects develop enormous accretion disks made of hot material. The light emitted by these disks can be visible from billions of light years away, sometimes outshining their entire host galaxy. Such objects are known as quasars. The second type of black hole is much more common, but significantly harder to detect. These include stellar mass black holes, which have masses comparable to that of a star. At the end of their life cycle, massive stars collapse into black holes, which can then grow over time by pulling in other celestial bodies and interstellar gas. Some of these black holes may evolve into intermediate mass black holes as they continue to accumulate mass. Additionally, when they merge with one another, they produce gravitational waves that ripple across space for millions of light years. The third type of black hole is purely hypothetical, primordial black holes. The existence of these objects is inferred from theories about the formation and evolution of the modern universe. In the early stages of the cosmos, fluctuations and vibrations in the distribution of matter might have led to the creation of infinitely small black holes. However, calculations suggest that the smaller such objects are, the faster they evaporate, ultimately ending their life cycle in a powerful electromagnetic explosion. According to theoretical models, primordial black holes with masses around 10 to the power of 12 kilograms should be reaching the end of their lifespan and exploding in the present era. However, no such event has ever been observed. Furthermore, it has been proposed that microscopic black holes could form as a result of ultra-high energy collisions between fundamental particles. Since these objects would be governed by quantum mechanics, they are also referred to as quantum black holes. However, the conditions necessary for such an event have not yet been achieved in a laboratory setting, and their lifespan is so short that detecting them with current technology is nearly impossible. As a result, quantum black holes remain purely theoretical. Detecting such dark and compact objects is, of course, extremely challenging. Some black holes have a stellar companion that exhibits abnormal orbital motions, and by observing these movements, invisible black holes can be identified. Another common method is analyzing the accretion disks. The spectral characteristics of the light emitted from these disks help distinguish them from other cosmic light sources. In some cases, it is even possible to obtain an image where a dark spot is visible at the center of the accretion disk, revealing the extraordinary nature of the observed object. Additionally, black holes can be detected through gravitational microlensing. This requires a massive yet invisible object to pass between Earth and a distant star, bending the star's light in a specific way. However, for this method to work, several rare events must occur simultaneously. Considering all these factors, there is no doubt that space is filled with countless dark and difficult-to-detect celestial bodies. Among them, there may be rogue black holes drifting through the void, silently absorbing even the faintest traces of light without leaving a single clue. These enigmatic objects will likely remain forever unknown to humanity. There are still many mysteries waiting to be solved about black holes. But what about you? Do you think there could be even larger and more terrifying black holes yet to be discovered in the universe? Or do you believe that one day black holes might pose a real threat to humanity? Share your thoughts in the comments and join the discussion. Exploring the mystery of black holes together was an incredible experience. If you want more content like this, don't forget to subscribe to my channel and like the video to show your support. I look forward to reading your comments. Until we meet again.